Hello, and welcome to another episode of NASA Science Live. My name is Karen Fox, and I'm NASA's Senior Science Communications Officer and your host for today's episode. It's exciting to think about all we can learn from these two new missions to explore Venus. And later in the show, you will have the chance to hear from scientists about each of these new missions, ask them your questions, and learn why Venus is such a fascinating planet to study. But first, we have two special guests here to tell you more. Let's hear about this exciting announcement from NASA's new Administrator, Bill Nelson, and NASA Science Associate Administrator, Thomas Zurbuchen.
Well, I'm so excited to be here with you on camera. Our new Administrator, Senator Bill Nelson, I'm just so glad to be working with you and learning about your passion you have for all things space and also of space science. And we're here because of those two Discovery missions focused on Venus.
Indeed, I'm just honored to be here with such a notable scientist as yourself, Dr. Z. And we're proud to have you a part of the NASA family. Now, tell us a little bit about these two missions to Venus.
So first of all, you just said they're missions to Venus. Now, be aware we have not been on Venus for over 30 years here at NASA.
Wow.
And so basically of all rocky planets that are in our neighborhood, it's the one planet we know the least about. So the two missions called Veritas and Da Vinci Plus will map the surface of Venus at 100 times the resolution we know today and will analyze the atmosphere that has the whole history of that very thick atmosphere of Venus, really making the first such measurements ever.
So as we move away from the sun, there's Mercury and then there's Venus with a very thick atmosphere. And the next one out is Earth with a habitable atmosphere. And then comes Mars with a very minimal atmosphere. So we're going to find out why Venus has such a thick atmosphere and why it traps all that heat, like the greenhouse effect, that it can even melt lead on the surface. Tell us about that.
It's absolutely incredible. And what's so puzzling about it is we think that if we looked at, let's take Venus, Earth, and Mars 3 billion years ago, they would be roughly the same. Modest type atmosphere, and as you said correctly, the planet Venus went a really horrible track, right, kind of trapping this, and frankly, we don't know today why that is. We know the greenhouse effect is a really important part, and of course, that's something we worry about tremendously at Earth as well.
Enormously, because we are heating up. The more we put things like CO2 and methane up in the upper atmosphere, it's going to trap that heat, and we'll continue to see the effects of heating of the Earth. As we learn more about Venus, how is it that we learn enough to be able to discover more solar systems and other galaxies with other planets that we call exoplanets?
I love that. Kind of when we made the selection, we were focused on that just the same way as you're indicating. We have over 6,000 planets that we've discovered, and so many of them are what we would call Venuses. So they're like a little bit like, rocky planets like the Earth, but they have very strong atmospheres. And frankly, we don't know our Venus. So how could we understand these other Venuses all over the galaxy around other stars?
Well, I'm so excited about this. Not only are we going to send humans back out into the cosmos, further out of low Earth orbit, but we're also going to be concentrating on science. And part of our science is that we're looking at planetary science to find out what's out there. Is there more life out there? This is an exciting time to be at NASA.
Yeah, I'm so glad to be at NASA with you right now at this time, and I couldn't be more excited about all of these topics. With humans going away from Earth, frankly, we're opening up new ways of doing science as well. And so we're really excited we're cheering on the humans out of the science directorate, just like our own robotic ambassadors that are going all over the solar system.
Thank you, Dr. Z, and thank you for joining us today.
As you've heard, there is so much we can learn by studying Venus, from insights into the evolution of planets to clues about planets outside our solar system. There's so much to gain. Let's take a deeper dive into this mysterious planet.
Mysteries abound in our universe, but bit by bit, we are unlocking its secrets. We now know that our galaxy contains billions of other planets, but how can we learn more about them? What traits do these exoplanets have? What are they made of? What are their environments like? How have they evolved over time? Are they habitable?
Hear from two experts to tell us about these new missions. And remember, throughout the show, you can send in your questions using the hashtag AskNASA or commenting in the stream wherever you're watching this. We're now joined by two very exciting guests, Dr. Jim Garvin, the principal investigator for the Da Vinci Plus mission, and Dr. Sue Smrenkar, the principal investigator for the Veritas mission. Thank you both for being here.
Thanks for having us.
So first of all, congratulations on the big news. It must be so exciting to have your mission selected. Can you both tell us how it feels to have gone to this point? Why don't we start with Dr. Garvin?
Well, Karen, it's beyond enthralling. It's actually beyond words. For me personally and for our team on Da Vinci Plus, carrying the name of Leonardo to explore Venus, this mystery exoplanet next door, it's just mind-boggling. We're going to go back in time to understand a world that's been a lost horizon. And by bringing ourselves there with the best of the technologies we have in our measurement systems, we're going to open up the Venus frontier for everyone. And the people of the planet Earth will go with us. So we're ready to go. Thanks for the opportunity.
Yeah, it's absolutely exhilarating. I think it must be like what it means to get on a rocket and be strapped in and blast off away from Earth's gravity. It's just been an incredible ride. We are super excited, the entire team. In fact, the entire Venus community. We won the double lottery, Veritas, Da Vinci together. It's just amazingly exciting. We so many of us have spent decades, in fact, working to this moment. So it's an incredible ride, and we can't wait to get the keys and start revving up and building our spacecraft to take us to Venus.
Well, congratulations. So here we are. We have just selected these two new missions to explore the mysteries of Venus. Could you each explain the goals of Veritas and Da Vinci Plus? I'd like to know how they differ and in what areas will they work together. We'll go to Dr. Smrenkar first.
Sure. So, as you heard about in the conversation with Senator Nelson and Dr. Zurbuchen, we really want to understand rocky planets. What makes them habitable? What makes them tick? Both in our solar system and in other solar systems. Veritas and Da Vinci are really aimed at that. We want to, on Veritas, get a global view of the surface of Venus. We'll be peeling back the clouds using special instruments to see through the clouds and revealing the geologic history. We're looking for processes that are active today, and really understanding how the interior of Venus, from its core to its surface geology to the volcanoes that help create the atmosphere, how they all interact and help build a habitable planet in the past, and where it went wrong to become this supremely uninhabitable planet today. Oh, and I'll just say, sorry for the interruption. I'm thrilled that Da Vinci is there with us because we really have great synergy. We'll get the global view and they get the close-up. This is just what the Mars missions have been doing for decades now, having the global orbital view and finding super exciting science targets, and then going down to the surface in detail. So, it's just a great pairing of these two missions.
Well, thanks, Sue. And Da Vinci Plus is like a flying rover chemistry lab that descends through the atmosphere from the cloud tops to the surface, making measurements by ingesting the atmosphere and measuring it. We're bringing sample return to Venus through our meter-scale probe that will see the surface with human-scale eyes in 3D and compositionally as we take the plunge. And our spacecraft will unravel the history of the key chemical constituents in the atmosphere, which are like the fingerprints of the processes that Sue was talking about locally. And that atmospheric record will tell us the history of past and perhaps lost oceans. We'll measure the cycles of carbon and oxygen and hydrogen and sulfur and phosphorus, which all put together this massive atmosphere. Venus is telling us something because it has this big atmosphere. We're going to go there back to that lost horizon with our mission to connect those dots so we can see Venus up close, and as Sue said, and globally, so she can become the exoplanet next door that tells us how to discover exovenuses and how they work beyond our solar system. We literally cannot wait to get started working together with our partners at Veritas. This is going to be an epic ride, trust me.
So let's talk more about this planet. Venus is not the closest planet to the sun, but it is the hottest in our solar system. Between the intense heat of 900 degrees Fahrenheit, the corrosive sulfuric clouds, and a crushing atmosphere that is 90 times denser than Earth's, landing a spacecraft here is incredibly challenging. Of the 9 Soviet probes that have achieved the feat, none lasted longer than 127 minutes. So, Dr. Garvin, can you tell us how Da Vinci Plus will withstand these harsh conditions and plunge right down into Venus's atmosphere?
Well, what we're going to do is make our instruments comfy. That's key. So the instruments won't feel that harsh atmosphere that you can see here, the sulfuric acid, the dense pressures, the supercritical fluids near the surface. We will encapsulate our instruments so we can make those telltale measurements hundreds of times while also imaging this exotic landscape that today may look very hostile and alien, something out of Star Wars or Star Trek, but in the past may have looked like this. An ocean world, perhaps an ocean world that started life like Earth for billions of years. We can read that record through the measurements we make by protecting our instruments to give us that wild ride. It will be a magical mystery tour as we make the measurements to put together the history book of Venus.
Fantastic. Now, Dr. Smartcar, I understand that Veritas will chart surface elevations over nearly the entire planet to create 3-dimensional reconstructions of topography and confirm whether processes like plate tectonics and volcanism are still active on Venus. So can you explain to us why it's important to understand these particular aspects of the planet?
Sure. Yeah. I mean, we're kind of exploring the once and future Earth, in effect, by going to Venus. As we've talked, Venus has this incredible greenhouse atmosphere today, but, it was once much more habitable. And by actually studying the processes that are, we believe, active on the surface today, we can, in effect, go back to the very early start of Earth's history. Earth probably looked a lot like this, as well as Venus in its early days. And the process that has been the dominant factor controlling the Earth's surface and much of its atmosphere is plate tectonics. So on Earth, plates move past each other and the process of subduction allows plates to sink into the mantle. And we think that that step of one plate sinking into the mantle is the very first step in plate tectonics that has, set Earth down this path of becoming habitable and, developing continents, developing oceans. But what about Venus? We would think the same process would happen on Venus, but so far it seems to have only given us subduction. So we can go back effectively to the very first billion or 2 years of Earth's history and understand that process of how does plate tectonics, this incredibly complex process, how does it start? What are the conditions that allow it to happen? And that's a really important question for being able to, look at just the density, the size of exoplanets around other stars and say, are they likely to be habitable? Are they likely to be like Earth 2.0?
All right. So why now? What has advanced in technology since we visited Venus in the 70s and the 80s? Now, I'll start with Dr. Garvin this time.
Well, everything. Technology, science results, modeling, what we've learned about our solar system, our universe, our planet, is just an amazing paradigm shift. And so what we thought we knew in the 70s and 80s has been transformed by Venus missions, Magellan, the Venus Express, Agasaki from Japan, but also by our capabilities. We have instruments now we can encapsulate to measure things 100 times finer than we were able to measure in the 70s and 80s. And by bringing that powerful transformative knowledge, we can probe Venus' atmosphere, measure her surface in ways that were unimaginable 30, 40 years ago. And that's why we're going back. Venus is calling us. The questions the science community have now about past habitability, how does a planet lose habitability? I mean, I lose change, not habitability. We want to understand how Venus lost that, because that's part of our own destiny, perhaps. And reading Venus record book through chemistry, through landscapes, through global studies like Veritas will change everything. And if we don't get to know our exoplanet next door, how will great new missions like the James Webb Space Telescope connect our solar system to the exoplanetary systems beyond? That's a key question. We can do that with the modern techniques of today. Da Vinci Plus and Veritas will both do that in the 21st century. I can't wait to go.
Yeah, and same holds for Veritas. We are building on the discoveries of past missions and the technologies developed to study the Earth, to study other planets. We have to look through the very dense clouds. You've been seeing these images of Venus's cloud cover. We have to use special tools to peer through those clouds, and we are building on instruments designed for the Earth. We're going to fly the first ever instrument, so-called spectrometer, that can look at the composition of the surface by peering through the clouds. So, from those instruments to the cloud cover, we'll be able to get an entirely new look. And yeah, in this image, you're seeing what the topography of Hawaii looks like. This is what it looks like currently in the data we have from Magellan. You can see that there are some high points there, but we're just going to be revealing exquisite detail. You can see the calderas at the top of the peaks. You can see fault lines. You can see individual flows. So we'll get just an unprecedented look at the surface of Venus.
Thank you so much. We are also getting questions from online. There's so much interest, and the questions are coming in on social media. So for everybody watching, remember you can join the conversation by submitting your questions using hashtag AskNASA or commenting in the stream wherever you're watching this. And let's start with a few questions now. Our first question is from @VanilSahu on Twitter, who asks, is there any reason behind naming the missions Da Vinci and Veritas? Let's do Da Vinci first and then Veritas.
Well, who doesn't love Leonardo da Vinci, the great Renaissance thinker, innovator, artist, scientist, technologist? He invented helicopters. He painted the Mona Lisa. So what we want to do in taking his name, which is also the acronym for our mission, Deep Atmosphere Exploration of Venus with imaging and measurements of chemistry and noble gases, by taking his great name, cataloged in 500 years of history, and applying it forward to Venus, we want to see the new Venus rising in the view of Leonardo. And Leonardo painted the Mona Lisa, one of the most famous paintings of all time. We think there's a Mona Venus waiting, and we want to discover that together for all of humanity. Wouldn't that be beautiful?
Well, Veritas is also an acronym. It stands for Venus Emissivity, Radar Science, Interferometry, Topography, Interferometry, and Spectroscopy. But it means truth. And, it's been so long since we have been to Venus that there are these ideas from about 30 years ago that I like to call myths that are still floating around about Venus. But we've learned so much about the Earth and other planets that they are really outdated ideas, and we are excited to bring new instruments to Venus and reveal the truth about Venus.
That's a very good answer. I like it. At KDasgupta18 on Twitter asks, which side of Venus will the exploration be carried out? The warmer sunlit side or the colder sun-hidden side? I'll start with Dr. Smarkar for this one, and if Dr. Garvin, you want to add on, feel free.
So as an orbiter, we see both the sunlit and the dark side of Venus. So we're constantly going around the planet and going from one side to the other, in fact. One of our instruments likes to primarily image on the cooler night side, our spectrometer that will allow us to get at the composition of the surface. So that instrument only operates on the night side because the glare off of the clouds is too intense to allow us to see the surface on the day side, but our radar instrument can see the surface all the time. So for the most part, we are operating on both sides.
Well, and Karen, if I may add, for Da Vinci Plus, we're going in with our probe, our flying rover, on the day side over a mountainous region known as Alpha Regio, the first radar bright area seen from Earth with radio telescopes like Arecibo. And so we're going to land in this mountainous zone. It's twice the size of Texas. That's pretty big. And we're going to come in there and see the atmosphere on the sunlit side, so we have lots of illumination. You might think it's dark on the day side of Venus, but it's not. And as our probe comes through the clouds, roughly at maybe 90,000 feet, we'll start to see that surface. And it will get sharper and sharper. We'll measure its composition. We'll see it in 3D using new machine vision methods. And eventually we'll see human scale features as if we're coming in on a helicopter or in your backyard drone. So we're going to use the day side. But as we get there, we're going to visit Venus twice on flybys, taking movies of the upper cloud dynamics using ultraviolet cameras so we can track cloud motions to look at the climatology. So while we go in on the day side, we will also see some of the big Venus that Sue's mission will see.
Great, thank you. Our next question is also a Da Vinci question. It is from Sohaib241-88610, who is from Twitter, and asks, can the Da Vinci Plus probe capture images of the surrounding landscape after it lands on the surface?
So the Da Vinci Plus mission does not require landing. We call ourselves a landerless lander because we make measurements all the way through the atmosphere as if we're landing ourselves, and then we don't have to land because we'll get all of our data. As you can see, the probe being released from our mother spacecraft developed by Lockheed Martin. We'll get all those data back through our mothership back to Earth. But if we survive landing, we have the capacity to operate for a few tens of minutes. But we think our final images and final chemical measurements made maybe 100 meters above the surface, and here we're in the clouds, flying through that area about 100,000 feet high, will show us features as small as baseballs, hockey pucks on the surface. So we could see that Venus almost as if we've landed. And the probe has instruments that can measure the chemistry, temperature, pressure, composition, all the way down, literally as a kind of a drive-by chemistry lab. So we don't have to land to do our mission. It would be great if we did, but we're going to Venus.
All right. Next one, I will also start with Dr. Smarkar, but you may well want to join in, Dr. Garvin. This is from @RedClicks on Twitter, who's asking, what really inspired NASA to return back to Venus? It is really exciting. At the same time, it's very challenging to accomplish this hottest planet destination. What are your thoughts? Why do you think we're inspired to go back to Venus?
Well, so many reasons, but we heard from the interview with Senator Nelson and Dr. Zurbuchen about the different atmospheres and the different surface temperatures for Venus and Mars. And so, Earth is kind of like the Goldilocks planet. It's just right, and Mars is cold and barren today. Venus is super hot, and Earth is just right. So, we've learned so much in the past decades about Mars. And of course, we're learning new things about the Earth all the time. So we really need new data for Venus to be able to understand what it is that makes Earth unique. Why is it the only place we know of yet that has life? Why is it so supremely habitable today? We need data from Venus to be able to answer this mystery and look for similarly habitable planets around other stars.
Well, if I may add, Karen, I would say, and agree 100,000,000% with Sue, but it's because it's time, folks. If we ignore our sister next door, what do you think that says? I mean, I guess we ignore our neighbors sometimes, but in this case, we don't want to, because she has so much to tell us. And yes, she's hard, but the engineers of planet Earth, those women and men that make things possible, that we just talk about all the time, they're going to let us do Venus right, so we can use what she's trying to tell us. She's been trying, literally wailing at us over the last 30, 40 years to come home, to come back. And there's Venus, as you can see from Magellan, a beautiful view. We need to go back because the time is right. We have the tools, we have the people, we have the models, we have the interest, and wouldn't it be horrible if we didn't know our sister next door and started to see this plethora of exovenuses that Dr. Zurbuchen was talking about? There may be dozens of them that we see with our James Webb Telescope. We have to measure our Venus to understand those Venuses. That's what it's all about.
Thank you. The next question is from William on Facebook, who asks, what materials will be used to keep the spacecraft from melting? That's probably a Da Vinci question for starters, but Veritas may well have its own thermal constraints to work with.
Well, Venus is hot and hard, as good question, but we're building, our spacecraft is about a meter diameter, spherical or hemispherical titanium pressure vessel. It's like the bathyscapes that carry great ocean explorers. You can see the Da Vinci probe there. It's about 3.5 feet across. It has spin vanes, so we can take beautiful images all the way down. It's made of titanium, and inside we use a phase change material to keep the temperature just right for those exquisite instruments that measure the chemistry. And we have other techniques, a special kind of seals that allow just the atmosphere in when we attempt to make those ingests of atmosphere, and at other times don't let it in. So this technology, it's worked before for our colleagues in Russia. We used it in the late 70s. We're advancing it to the 21st century to open that Venus frontier so we can go there and be there.
Yeah, and we have a much easier job in the atmosphere than Da Vinci has going to the surface. But there's still a lot of heat that reflects off the clouds, especially on the day side. So we do have extra material on our solar panels that allow us to reflect some of that heat and make sure there's not too much of a temperature gradient from one side of the spacecraft to another.
Great, thank you so much. We're still going. Remember, you can send in your questions to @AskNASA. Sorry, that's hashtag #AskNASA. Next up, we have a question from @NickBE24 on Twitter, who asks, what data are you hoping to collect through these missions? We can do Dr. Smrekar again first and then Dr. Garvin.
We are excited to be collecting a number of different data sets: global topography, global radar images. We will get data from our spectrometer about the surface composition. We use that data to look for recent volcanism. We can get thermal signature of active volcanism. We will be looking for gases coming from volcanoes, and water in particular, given off by active volcanoes. So, and then lastly, we take gravity data, which tells us about the core, about the mantle. And I just want to say we're also taking data to measure active deformation on the surface. So we have a bunch of different ways to see the surface.
Well, on Da Vinci Plus, our job is to make hundreds of exquisite chemical measurements. Again, as I said, an order of magnitude better than ever made before, and hundreds of times. We will make a complete transect of the atmospheric chemistry. We will sniff the inert noble gases and look at their isotopic ratios. That's a big word. Sounds like it's out of jeopardy, but it's not. It's something that allows us to piece together the past history of Venus. Why was atmosphere changed and oceans lost and volcanoes erupting? We can read all that through the measurements we make in the atmosphere from our chemistry measurements. We'll also take hundreds of descent images through our surface port right at the bottom, sapphire window. Will let us see the surface bright and sharp, just like the landings on Mars, only we'll do them in 3D with composition. So we'll be able to measure what the rocks are like locally to compare to Sue's measurements to the global ones from Veritas. And in the mountains of Alpha, we're thinking these could be an ancient continent with evolved rocks like you find in the mountains of New England or the Canadian Shield. So we'll make those measurements and pressure, temperature, accelerations all the way down. It'll be a wild ride. And that data will be a boundary condition for scientists for generations to come.
Thank you so much. We have a lot more questions coming in from social media and online, but all of you sending your questions are not the only ones excited about these new solar system missions. So we're going to hear from some other Veritas and DaVinci Plus mission team members.
NASA is returning to Venus after 30 years.
We are going back to Venus, and our team of managers, engineers, scientists, technicians, and instrument developers are ready.
I was extremely excited to get to compete with other professionals to try and put a new mission around Venus.
Hi everybody, and good morning. I'm in an environment right now that is as different from Venus as you can possibly be. We have water, we've got ice, we have trees.
Venus is one of the most enigmatic worlds that we know of. We have so many unanswered questions about the planet next door.
How did Venus form? Did it have oceans? Where did the water go?
How Earth and Venus became so different. What makes a rocky planet become habitable and what makes it not?
What ancient climate may be preserved in the rock record? You know, these are the compelling questions that drive me to study Venus.
I am passionate about Venus because it's been a puzzle that has confounded us for so many decades.
Venus promises those answers.
We're going deep into the atmosphere, learning about the atmosphere. We're going into orbit to get some long-term images, and this should be a fantastic mission.
I also, as a geologist, I'm anxious to see the surface of Venus with my own eyes, as it were.
I imagine what it is to be in the cloud of Venus, to travel through the transparent hot atmosphere below, and especially the environment near the surface where the air is so thick that in some way we are between a gas and a liquid.
In my wildest dreams, we're going to find a Venus that is even more volcanically active than what we observe on Earth today.
The secrets of Venus' past habitability will allow us to understand the evolution of Earth-sized planets around other stars.
I am very inspired and very happy to continue in the business of exploration, but also the business of inspiration.
We're looking forward to bringing the scientific community and the public along with us on our adventure.
This is a really exciting mission, and I am so proud to be part of it.
I can't wait for the data from DaVinci.
Working with a beautiful spacecraft with clever mission design and state-of-the-art instruments, and making that happen, it would be tremendous fun, and looking forward to it. Go Veritas.
And go DaVinci Plus.
It is so great to see all the excitement and enthusiasm around these new missions. Speaking of excitement and enthusiasm, let's go back to the questions from all of you at home, sending them in. We have Canal A on YouTube who asks, will there be new technology on the missions to Venus that hasn't actually been invented yet? I'll toss to either of you.
Well, I can just say the technology of encapsulating the next generation kind of instruments we're flying to Venus, the kind that are operating on Mars now in conditions that are a lot more clement, had to be invented for us to even have a chance at flying these missions. These are competitively selected missions by Dr. Zurbuchen and the colleagues at NASA. So we have to compete for the right and the chance to do that. And so the technologies we invent are invented now to go to Venus. And we hope we can test new technologies as part of our technology demonstration experiments to even extend that further. And we have one on DaVinci Plus to measure the hyperspectral composition of the upper clouds of Venus, to see what are the mystery absorbers like. This is the kind of future casting we want to do at NASA that's just emblematic of who we are.
Yeah, I mean, we have another technology demonstration on Veritas. It's called a Deep Space Atomic Clock, and it is incredibly accurate. And by bringing that new technology development along, we can help improve our ability to measure the motion of our spacecraft and use that to sense the interior of the planet, to sense the gravity field. and it'll help future missions as well to be able to provide even better data for the interior of perhaps icy moons or other bodies where they can fly the Deep Space Atomic Clock in the future. And Veritas has a lot of excess launch mass, so it's entirely possible that NASA will decide to add another payload on that's being developed as we speak and maybe selected in future competitions. So stay tuned. We'll see what we actually launch with.
Great. Zero Shuki on YouTube asks, how are you going to keep the spacecraft up and running as long as possible since most die so fast? I'm going to tweak this slightly to add just about how long each mission is expected to the lifetime of each mission. But I think it's a starter question for Da Vinci with going down onto the surface.
Well, our mission is a little over 2.5 years. We actually launch and fly by Venus twice to collect special atmospheric remote sensing data. We're all about the atmosphere. We think that's the history book of Venus that we want to read. And so we'll make these maps of cloud motions. We'll look at the atmosphere as we look at that of Earth. You can see the Earth here as we launch to Venus. So we're very excited about that. But then our final mission, we release our probe, and you can see us being released on our trans-Venus injection after we launch. But it'll take us about 6 months to get to Venus. We'll fly by Venus twice, and then going around the sun, we'll come back and we'll release our probe 2 days out, and then our probe spacecraft, again, in an aeroshell, will fly through the atmosphere for about an hour and reach the surface, landing at about a speed of maybe 20, 25 miles an hour. And during that time, we'll collect thousands of data sets of a new type: chemistry, imaging, composition, pressure, temperature, see the lower surface of Venus for the first time in this new way. And so the overall probe mission will be about an hour. If we survive in the surface, we may have another couple of tens of minutes, and then our spacecraft will play all that data back. So that's our mission lifetime.
And for Veritas, we get to Venus very rapidly, in about 6 months. And then we spend quite a bit of time going from a big orbit that goes out, 10,000 kilometers, and then bringing that orbit down slowly to being just a few hundred miles above the surface. So we actually use our solar panels to effectively act like drag flaps. You have a spoiler in the back of a racing car. Well, we use our solar panels instead, and we dip gently into the atmosphere, and it slows us down over the course of about a year. And in that time, we get into the precise orbit we need to be in to get the best performance out of our instruments. So, after about 2 years, we're ready to start taking our science data, and we spend about 3.5 years acquiring science data, mapping in a series of global passes around the planet.
Thank you so much. The next one up is a Da Vinci question. John Spellman on YouTube asks, will Da Vinci Plus be able to detect phosphine molecules? What would it mean for future missions if phosphine was actually discovered by Da Vinci?
So first, Da Vinci has 2 analytical chemistry experiments. One can detect phosphine throughout the entire atmosphere, especially from the lower clouds all the way to the surface, where no species with phosphorus have been detected. So we will be looking for that with exquisite detail, like the measurements being made on Mars now with our instrument. We also have an instrument that's a very special one that uses lasers and scattering that can measure lots of great species, and we can adapt that instrument by adding a new channel, which is an option that we'll be pursuing in the next couple of years, to specifically measure the phosphine. That's such an exciting possibility for Venus. The bigger point, though, is we will measure the chemical context of all those interesting trace gases. Phosphine, which smells like swamp gas, but other ones that might be equally interesting that we haven't even discovered yet. And by producing that context, we can start to think about Venus as an astrobiological target. So it's not just phosphine. It's all of the context of the chemistry of this rich atmosphere that could have had a habitable cloud deck at one point in its past, or not. But we need the context to understand that possibility. That's how the astrobiology community has recommended we work, and that's what we're going to do with Da Vinci Plus.
Thank you. The next one is a volcanology question, so I'm going to toss this one to Dr. Smrekar. Srivatsa M on YouTube asks, a speculative question about Earth. If all the volcanoes on Earth started erupting at once, could that turn Earth to look into something like Venus in just a couple of decades?
It would
That's a
take
hard one.
a lot more. Yeah, and I will have to draw on some conclusions that I'll put together as we speak. But there are about a couple dozen active volcanoes on Venus, and there are many on Earth. Pardon me, and there are many more that haven't erupted recently. So if we take all of those and put them together, we would certainly have a very big impact on our climate, and we would feel that right away. But it would not turn us into a Venus. That would take probably hundreds of millions of years before you would get to such an extreme point as Venus is. And really the major difference between the climate of Earth and Venus is that on Earth, because we still have our oceans, the CO2, the carbon dioxide, is locked up in our rocks, in our carbonate rocks. That carbonate gas dissolved in the ocean and it precipitated out. It just sank to the bottom and created these carbonate rocks. And so, unless we release all of that carbon dioxide back into the atmosphere, we'll never become like Venus.
Good to know. All right.
For that fate, we have other things to worry about, but we won't get all the way to being a planet like Venus.
All right, next question. Lou on Facebook asks, is it true that Venus's atmosphere smells like rotten eggs? Who wants to take that one?
Well, I can give a stab and Sue can obviously finish. So rotten eggs, of course, is an acquired smell based on gases, compounds that involve hydrogen and sulfur. We'll be able to measure those. But however, most of the atmosphere of Venus is made of carbon dioxide with nitrogen and argon and other inert gases. So a portion of the atmosphere in the clouds you just saw is where we expect to find those special sulfur and hydrogen compounds. And that constitutes this really thick cloud deck that is very difficult to see through, needing instruments like Sue has. But we'll be sniffing those with instruments, not human noses, to measure what they're made of and tell you specifically, would they smell like rotten eggs or swamp gas or other things that would be very exciting to smell. And I think we'll connect the smells of humanity to the measurements of Venus when we fly our DaVinci Plus probe.
Well, I will leave it at that. The next question is Caden Kolbath on YouTube, who asks, how long does it take to get to Venus? Dr. Smrekar mentioned that. Why don't we go to you for this one?
Sure. Well, it depends on how close you are to Venus when you launch, but we have different possible trajectories that will get us there from anywhere as short as 4 months to as long as 9 months. But we're hoping for a sweet spot around 6 months to get there.
All right, I'm going to add on a slight addition to that question from @FutureStarman on Twitter, who's also asking how long until the missions are ready to launch.
Well, we could be as ready as early as 26. NASA has asked us to be ready to launch in 28. That works best for their phasing of all of their various missions. So that's our goal at the moment.
Right. NASA's dictated launch scenarios for us based on funding profiles, which we're grateful to have. And so our missions are scheduled for the 28 to 2030 timeframe to reach Venus. And so that's going to be a great time to go to Venus. James Webb will be flying. We'll be seeing exovenuses. Maybe they'll look like the Venus we see here from Magellan. So we can't wait. Sooner would be better, but we'll take anything.
All right, tell us a little bit more about Venus. We're getting some good questions about the planet itself. Sonia on Facebook asks, does Venus have gravity?
Well, I can take that one. We're going to measure the gravity field of Venus very precisely. And absolutely, it has gravity. It's, sorry, I keep going the wrong direction here. But I need gravity to hold me in place. Yeah, so we are going to measure the gravity. It is just slightly less than that of the Earth because it is slightly smaller planet. So the gravity at the surface is about 10% less than on Earth.
All right, this one will be for you as well, Dr. Smrekar. Robert on Facebook asks, is there evidence that oceans existed or are they theoretical? Actually, I take it back. I think either of you can answer that, and Da Vinci is looking for oceans. So I may toss this one to Dr. Garvin. I got that backwards.
Well, Karen, I can take a stab, and I think Sue should as well. So the evidence of oceans is recorded in the measurements that were made from spacecraft in the late 70s that involved measuring what are called the isotopes of hydrogen. And that critical ratio of regular hydrogen and heavy hydrogen gives us an insight on how much water bound in hydrogen molecules was present. And we made that measurement thanks to Pioneer Venus Large Probe. And since then, high atmospheric measurements have been made by the Venus Express mission. And they show a possibility of very grand oceans. But the real exciting thing is, like you can see here, perhaps for billions of years through Venus history, the exciting thing is that new atmospheric climate models developed by the community around the world have shown us the possibility that if Venus works the way we think, and again, as Sue said, there may be myths about what we think until we measure more, but if it does, Venus could have harbored oceans for 3.5 billion years. What Da Vinci Plus will do is measure that ratio at exquisite precision 10 times through the atmosphere, from above the clouds all the way to the near surface. And that will set the record straight. Did it have big oceans? Did it? When were they lost? How were they lost? Why were they lost? Those are key questions we can ask through the chemical measurements that we will make in context with Da Vinci Plus.
Right, and Veritas will take another slice at that question. We are looking for evidence of analogs of Earth's continents. On Earth, the continents that we live on formed when huge amounts of oceanic crust, the basaltic crust, iron-rich crust, melted in the presence of water. And so with our instruments, we're going to determine if these giant plateaus on Venus are in fact just like Earth's continents and are thus telling us about the history of past water, that crust melted in the presence of water and shows us that there's still this history of water locked in the rock record at the surface.
All right, thank you. Next question is from Shriyanash Singh on YouTube, who asked another speculative question that we cannot specifically answer for NASA, but it says, will far future Venus missions include a sample return system from Venus? And of course, we cannot predict what NASA will choose down the road, but if you know of anybody thinking about it or what samples might tell us, I'd love to hear.
Well,
and if we don't even think about it now, we can move on.
I was just going to say, Sue did a great study for a Venus sample return mission, so I think she could actually tell us how we might do that.
Well, there are a number of sample return mission studies in work, and so it's super challenging. We're looking at trying to do that for Mars right now, and perhaps the biggest challenge is getting that surface, that sample to back to the Earth, is getting it off of the surface of Venus. So there are a lot of studies underway to begin to address that question. And I'm sure we're going to learn a lot in the coming decades from the process of returning samples for Mars. So it's in the pipeline in terms of developing the approach.
All right, that's exciting. Thank you. Matthew Taylor on YouTube asks, how do you think the planetary science gleaned from these missions could benefit human habitation on the Moon, Mars, and beyond? I'll go to Dr. Garvin first, and Dr. Smrekar, please join in if you have other thoughts.
Well, as we explore, we learn how to extend the limits of our performance. So at Venus, we have challenges as we go into the atmosphere, and those technologies can produce new thermal regulation systems, like the heat shields that got the Apollo astronauts back from the moon, developed that were then used by the Viking project to get into the atmosphere of Mars to land two exquisite landers. That feed forward is typical of our missions, and we want to get the women and robots and next generation to the moon and, of course, to Mars. So what we do in all of our planetary exploration is build the piece parts. And we build them together in a mosaic of future capabilities that we can then use. And some of them extend to IT solutions. So we need to be able to process data, especially seeing things in new ways with camera systems and systems that measure chemistry. The environmental health of people will depend on some of the kind of instruments that we'll be flying into the atmosphere of Venus, for example. And we need that to keep the crews alive as they live on the moon and do their work through the Artemis program and the Artemis base camp. So there's always a feed forward, and we in NASA, I think, do a good job about capitalizing on that. So that's my 1 cent. I'm sure Sue will have better ones.
No, I think you said it well. Really, every technology that we develop and every mission that we build and send out into outer space, helps us learn lessons of taking the next steps. So I think I have nothing further to add.
Great. Well, we're talking about the moon and Mars. Let's bring it back down to Earth. At Planthony C on Twitter asks, what sort of context will these two new missions provide for climate data collected by the upcoming NASA Earth System Observatory missions? We can tweak that to at least how does it help us understand climate if you don't know about the ESO mission specifically.
Well, I can take a quick stab. So the ESO mission, starting with NISAR and other missions like Clario and PACE and on out, build on the climate history of our own planet, where we have an exquisite capability of modeling and predicting, and it's taking off. It's so exciting. And we apply that to worlds like Venus and try to backcast. And so by making the kind of measurements that both DaVinci Plus and Veritas will be making at Venus, we build the boundary conditions to cast those models for Venus. Today, those models are limited. We don't have adequate data. We don't even know the temperature lapse rate from below the clouds to the surface well enough to constrain some models. Well, how does it change? Well, we need that for Earth, of course, and we need the history of water. We need all these features. We need the topography of Venus as a primary boundary condition. We need to know why its very slow rotation will affect those kind of climate models. So we will learn from these missions and apply them, the lessons we learned for Venus, apply them to Earth. The same way we learned from Mars, and its very interesting topsy-turvy climate history, has also shed light on the history of climate on Earth. So there are always these connections as we go somewhere and apply it back home, in my view.
Yeah, there are just so many. Yeah, if I could just add, there's so many parallels between Venus and Earth. The people who discovered the ozone hole on the Earth that has a major effect on Earth's climate were actually people who were studying the chemistry of Venus's atmosphere, and they decided to go and look for ozone, and as a process, and in that process discovered this ozone hole. And similarly, people who have proposed using sulfur to try to help slow down climate change on the Earth. People studying the climate on Venus said, look, that's really not going to work because we see on Venus the breakdown of sulfur at the top of the atmosphere. So, there are parallels to the present day climate, but there are also parallels to the long-term climate. We think that Venus and Earth have similar amounts of carbon dioxide altogether, but on Venus, that carbon dioxide is in the atmosphere, making it this incredible, runaway greenhouse that makes it 900 degrees at the surface. Whereas on Earth, that same carbon dioxide is locked up in the rock record. And by studying processes of subduction, where the crust goes from the surface back into the mantle, that's effectively sequestering carbon dioxide, right? And so we're going to learn how that process may have started on the Earth. So, we could talk for a long time, but there are just so many parallels between Venus and Earth, and it's all essential to really understanding both the present day and long-term evolution of the climate.
All right, we are finishing up here with some of our last questions. At David Johnson VG on Twitter asks, when did you first find your own interest in solar system exploration? Let's do Dr. Smrekar first and then Dr. Garvin.
I was certainly a kid when Apollo astronauts were landing on the moon, and of course that was very mind-blowing and inspiring. But I think I did not completely imagine planetary geology, geophysics as a career until I got to college. And it was really there that I learned I could study how processes work on other planets. And I was completely hooked. It was just a fascinating idea of being able to do that. And so that led me to doing things like studying volcanoes on Hawaii as a means to learn about volcanoes on Earth.
Well, Karen, I like Sue, my mother said I was hooked at birth, but I don't know what that means. So we can all reflect on that. And so, but I was looking up at the moon as a little kid and saying, why aren't we there? And my parents said, well, it's a long trip and, you know, gas prices, not going to work. But like Sue, I was enthralled by Apollo and saw the Apollo 11 landings as a young kid and couldn't believe it. I was able to then transfer that through my college experience in high school to visit places that reminded me of Venus. Here, the impact site Shamanshine in Kazakhstan, the most recent big impact. And searching for Venus on Earth has always been one of my passions. Two of my advisors in college and in grad school told me, you better look at Venus, Jim, even though I was funded by Mars. So I basically reconstructed my whole graduate school career to study Venus and was able to participate in the Soviet missions to Venus, like the Venera 13 lander here that lasted 127 minutes. This is its sister sitting in Moscow. Here we are thinking about Venus 15 years ago when we started the Sojourn to become a mission like Da Vinci Plus. We were very excited about actually making it work. And here, the Eye of Venus with me, looking through the sapphire window that we now look forward to flying to Venus. So I was always dazzled, and I don't think I can ever let go. I can't actually stop working on it. So my family often tell me that. So it's science doesn't sleep. I can attest to that.
Thank you so much. That is all the time we have for today. And I really want to thank you both for joining us.
Well, thank you so much for having us.
And if you want more information on Veritas or Da Vinci, you can visit go.nasa.gov/new-Venus-missions. And you can also follow us on @NASA Solar System on Facebook, Twitter, and Instagram. Until next time, I'm Karen Fox.